Thank you. Hello, everyone. I'm Annie Dahlman from Sandia National Laboratories. I wanted to welcome you to this OES webinar on data and information sharing. Thank you very much for joining us. I'm going to give a really brief overview of what OES, or Ocean Energy Systems, is. The IEA Technology Collaboration Program on Ocean Energy Systems is one of the collaborative R&D programs established under the IEA, or International Energy Agency. OES was established in 2001 and since then has been conducting a variety of joint projects. There are now 25 members of the OES, which includes 24 countries plus the European Commission. The OES embraces the full range of ocean energy technologies, but this does not include offshore wind because seawater must be the mode of power. And for the purposes of this webinar, we are also considering marine renewable energy, or MRE, and marine and hydrokinetic, or MHK, which is often used in the U.S., to be the same thing, so they'll be used interchangeably. The Executive Committee has agreed to have the U.S. host this webinar on data sharing, and now I'll hand it over to Andrea to get into the details of the presentation.
Thank you, Annie. This is Andrea Copping with Pacific Northwest National Laboratory, and welcome this afternoon or morning, depending on where you are, webinar. What we are trying to do on this webinar is share some of the findings that the U.S. Department of Energy National Laboratories, Sandia National Laboratories, Pacific Northwest National Laboratory, and the National Renewable Energy Lab have been examining and gathering these needs over the past year or so, and we'd like to share some of that. We'd also like to talk about some of the risks and benefits of data sharing associated with marine renewable energy. We'd then like to talk a little bit about a vision for how data sharing and organization might take place. We've been examining this in the U.S., and so it's strictly sort of a U.S. vision at this point, but we'd like to sort of roll that out and see what you think. And we'd really like to invite you, the international community, to share your thoughts, what interest you have in data sharing. So that's really what we're setting out to do here today. And we're going to start by examining what we mean by data. Now, everybody has an idea of what that word data means to them, and often it could be raw data or quality controlled data, groups of numbers, but we're also using that term more broadly to include analyses that might appear in reports, laboratory measurements, various kinds of metadata. It could include videos and pictures, open source codes, GIS layers. We're really trying to talk about the whole group of data and information sources. Okay, in terms of how important data can be to the development of the marine renewable energy industry, we know that data and information can play a significant role in advancing technology. We have good examples from other industries, and we're already seeing that in this industry. We can help to solve environmental challenges, but we know that often collecting these data are expensive, they're difficult to collect technically, and then we have the problem of what to do with them. This is a very early stage in the marine renewable energy industry, so that this is really paramount that we collaborate together so we can progress and learn together. It's really not the time for competition just yet. We know that by gathering and sharing information and data, it's possible to accelerate an industry considerably. We have examples from the wind energy industry, from geothermal, aviation industry, and others that lead us to believe this will be equally true for marine renewable energy. The peacock diagram you see on the right of this slide is just to give you some sense of how data and information are used just in the context of marine renewable energy. It could start with data on resource characterization, maybe wave, tidal, or ocean current resources, all the way through the engineering and design aspects of turbines or wave energy converters, various kinds of innovation, monitoring of devices for their health within the operating environment. It could look at environmental baseline and assessment, could be used for model validation. So the three laboratories I mentioned set out to really understand what kinds of data and information needs might be out there, sort of a screaming need within the community. And we did this over the past year or so by talking with a lot of people. We held 2 workshops, one almost a year ago at the Marine Energy Technology Symposium in Washington, D.C., and another at the European Wave and Tidal Energy Conference in Cork, Ireland. We have a steering committee associated with this project with representatives from the marine renewable energy industry, from academia, from regulatory agencies, and other stakeholders. And we have talked extensively with industry representatives, academia, and the test centers. Through this process, we noted a number of major themes, and that colored swirl on your right is to represent those themes. We heard a lot about the importance of discoverability of data, that it is possible to go and find the data you want, know where it is, and be able to search for it. We heard about the importance of data integrity, how it must be quality assured, curated carefully, and archived. We were told that having a place to archive and keep best practices and standards is important so that practitioners in the marine renewable energy industry know where to go to find the latest guidelines and consensuses. We heard that any kind of platform or grouping of data really need to be a platform for outreach and communication to a wide variety of stakeholders, everything from the very technical through regulatory and policymakers. We heard that a place to keep, archive, and make accessible tools and codes is very important, once again, so that the practitioners can find the latest versions and know they are using the best tools. And we heard a lot about the need for accessibility of data, at the same time maintaining security for the databases themselves. So those are the themes that we heard about. And we examined what appears to be the state of data and information right now. We know there is a great deal of data out there, but often it's not readily accessible or public. It's often stored in many different locations and formats. Maybe it's on hard drives, maybe it's in file drawers. And it's often not easy to access because there aren't catalogs and descriptions of the data. So the little pictograms here are trying to think about all those kinds of data on the left disappearing into a black hole and leaving the users on the right baffled as to where to go to get the best information. And the reason this is so sort of detrimental to the industry is there are so many issues that can arise from this. That whole list of not knowing how to find data, not being able to do consistent analyses because you have different types and formats of data, having environmental studies taken in one place and not readily accessible for another project elsewhere, and so on and so forth. And it all really amounts to creating higher costs and longer development times for the marine renewable industry. So that's the sort of state we see at the moment. At the same time, we've really tried to think hard about what the benefits of sharing data might be. Again, we know there's the opportunity to accelerate innovation. By contrast to the disconnectivity, we believe we can reduce costs overall and also reduce development times, time to get in the water, time to get to commercialization. There is the opportunity to avoid duplication of effort. If you know someone else has carried out the same study, the same analysis elsewhere, you can build on that rather than starting and doing the same thing over. If we standardize data, if we have similar formats and understanding and descriptions of those data, we can do comparative analyses with a certainty that they really do mean something because we're comparing the same sorts of data. We can increase the discoverability of data and access to tools and codes and so on because, again, we know what these various data mean because they comply with certain formats. And this is also an opportunity to really promote collaboration among different members of the marine renewable energy community. A few quick examples of this. If we're talking about resource characterization data, having it all in one place will be a quick discovery of some of the really optimum development sites. It will also allow us to look where there are and plan to fill in areas where there is missing data. In terms of open source codes, again, we can quickly get the right tools and reduce the time and costs for analyses and simulations. In terms of environmental data, having this in one easily accessible location will lead to easy data discovery for regulators, which will help accelerate siting and permitting consenting. So with all that information in mind, in the U.S., we have set out to create a vision. And this is a vision for perhaps a possible future. It is not an established project. It is not a funded project. It is something that we have been thinking about and we'd like to introduce to you to get your reactions, to see what you think about it, to see how we can collectively improve upon it. We have called this PRIMRE because everybody needs a good acronym. This is the Portal and Repository for Information on Marine Renewable Energy, PRIMRE. The vision of PRIMRE is that it would provide broad access to all sorts of data, engineering design, resource characterization, environmental data on marine renewable projects, all with the purpose of helping to facilitate the MRE industry, especially towards commercial development. We see PRIMRE as establishing a data portal, an entry point. It should support access to online tools, codes, standards, and other up-to-date information of that sort. It should really set the context for how we can discover marine renewable energy data and information. And we believe this can lead to facilitating connections among different data sets, different types of information, and connections within the marine renewable energy community. So when we examine the situation in the U.S., this is pretty much where we are right now, this wiring diagram. And the boxes you see are mostly existing or under development data sets, data portals, etc., that the U.S. Department of Energy and others have supported. TESIS is the environmental effects collection of information. The MHK data repository has data from testing purposes, and so on and so forth. And I think what you see in looking at this diagram is that there is limited interconnectivity among these data sets and databases, and also back and forth to the end users who are represented by those little gray crowds of people. Furthermore, there is no common entry point. It's not clear how you would get into this system. So in thinking about this vision, PRIMRE, we have rewritten this wiring diagram somewhat, with PRIMRE at the middle being the common entry point. And from there, we have the opportunity for greater interconnectivity between and among the databases and data sets, but also back and forth to the user groups. So this is where we are in our thinking so far. We think the impact of PRIMRE can be, it becomes a centralized collection and dissemination point for information. It will provide good access to online tools, And if you don't see the tools you think of there, imagine another little blue box with what's needed. It should access existing information well in an organized format so that the user can get to what they want, find out if what they want exists, and get to it quite easily. And it should be a method of integrating different data sources, bringing together disparate data sets to try to bring something more out of the collection. So that is our vision. Again, not implemented, but a vision at this point. Now I'm going to turn this over to John Weirs from National Renewable Energy Lab, who's going to talk a little more about why we want to do this. John.
Thank you, Andrea. Yes, I'm John Weirs from National Renewable Energy Lab, and if you're imagining yourself as part of this wiring diagram, you're already 2 steps ahead of us, and we really appreciate it. If you're not, I'm just going to take a brief moment to talk about why we think collaboration and cooperation amongst data partners is so essential to the future of MRE technologies. And that is, quite frankly, that the traditional model of, doing your research, innovating your technologies, building your prototypes, and locking that data in a drawer is just antiquated. Data locked in a drawer is a wasted resource. The Department of Energy in the U.S. stated way back in 2011 that success should be measured not when a project is completed or an experiment concluded, but when scientific and technical information is disseminated. What they're saying with that is any knowledge gain is essentially wasted if it's just locked away in a vault, unless it's transmitted to another individual. And that's not to say we all need to share everything and give away our trade secrets, but if we're really going to extract the value from our data, we have to put it to work for us. And as Andrea so eloquently mentioned earlier, data that's open and shared really does help advance the adoption of MRE technologies. It really does fuel innovation, and we've even seen instances in other sectors, wind and geothermal, where having these data available to the public has allowed people to not only advertise their successes, but also, in some cases, secure follow-on funding to further their research and take things to the next level. And so, contrary to the popular superstition of sharing your data just means your competitors are going to get it, what we're seeing is, in many cases, when people do put forth their data or portions of their data, would-be competitors are showing up at their door as collaborators and willing to help work on the next phase, or in some cases even bringing money to the project to help fund the next phase of development. And that's exciting. I have a really interesting story about the data. It's not always the polished, finished product or result that's of value. In many instances, it's the raw data that's of value, data that's dirty and munched and that you might think not necessarily useful to anyone outside of your project can often have the greatest utility, because any summary information or finalized report is by its very nature filtered towards the end goal, whereas raw data remains reuseful. It remains free to be used in any context. And there's a wonderful story about this coming out of NOAA, the National Oceanic and Atmospheric Administration in the U.S., a while back released their raw radar data to the public. So formerly they had been making all of their scrubbed, polished radar data available to the public in the form of cloud and precipitation maps, being used in weather forecasts and accessed by multiple layers of data partners. That end result was, weather forecasts in the U.S. But they decided to release their raw radar data, and a few people started picking it up and playing with it, and one grad student in particular decided that they would write their own radar scrubbing algorithm and to clean out all the background noise, to get rid of airplanes and bird traffic and ground reflections. And they were able to do not only just that, but more successfully than the existing NOAA algorithm. And so when they published their thesis and generously gave their algorithm back to NOAA, It resulted in much more accurate precipitation maps, and essentially, as a result, NOAA adopted it, and overnight, virtually every weather forecast in the U.S. became more accurate. So that's a very direct, tangible result of collaboration, data sharing, giving somebody else a try at something you think you've already done. But what's really exciting to me is the unexpected, the utility of a data set that's taken and used in a totally unrelated field. And so a group of ornithologists came along and found that same raw radar data, and they applied the opposite algorithm to it. They scrubbed out all the clouds, they scrubbed out all the weather data and ground reflections, and they were left with the most detailed, comprehensive data set of bird migrations across the U.S. radar network. And so that is just a really fun example of how data that is being consciously discarded by one group of people might be intensely valuable to another group of people. So we've had a lot of success stories throughout the years in different sectors, including marine and hydrokinetic. I have the luxury of running the Department of Energy's Marine and Hydrokinetic Data Repository, which houses data from DOE-funded projects. And we've built upon the successes of these data sharing stories we've heard in the past. The MHKDR, as we call it, is actually built from the ground up to share information. And so any data that are added to the MHKDR are automatically propagated to all of the data partners on this slide and many more, actually. So they show up on data.gov, they show up in worldwidescience.org, they get digital object identifiers and go through the Thomson-Reuters Data Citation Index, where it generates a little mini press release for every new publicly available data set. And what's more important is even before a data set's publicly available, we will advertise its presence by publishing the metadata of that data set, saying, hey, this data set exists. It might not be ready yet, it might still be being curated, or perhaps it's undergoing some sort of proprietary phase where it's under moratorium for a brief period, but it will be available soon. It will be available on this particular date. And there's a tremendous value even there. Even just announcing that data exists, but you can't have it yet, is immensely helpful to the greater MRE scientific community, because it lets people know that, hey, somebody else is actually working on this or has completed this work. The data is just not publicly available yet. And so we provide, along with that metadata, of course, a contact for that information that allows people to reach out to those individuals and say, hey, I'd like to collaborate while you're working on this, or would it be all right if I received an advanced copy of your findings, and let them make those human connections. And so I think the utility of a system like this designed to share information has been very beneficial to the community domestically, and we'd like to extend that internationally. We'd like to incorporate that into the greater MRE scientific community. But there are, as we've mentioned earlier, many benefits to sharing data. There's many reasons why you'd want to share data. There's lots of utility from doing that. There are also some challenges to sharing data. And when people think about challenges of sharing data, many times they're just thinking about the technology. You know, it's sort of the tip of the proverbial iceberg. And then, okay, I don't have sufficient metadata to describe this, or my data is in a proprietary format and I need to convert it before I could share it, or somebody would have to buy a license. They're often thinking about data transformation issues, the conversion. They're thinking about the hosting. You know, well, if I'm going to share this, I have to put it online, which means I need a website and some sort of IT professional to help me out with that. And those are certainly concerns. There are other concerns as well, even in the technological challenges. Discoverability is a big issue. Just because something's online doesn't mean it can be found. You need to make sure your data is discoverable, that it's got the proper keywords attributed, that search engines can find it and so they can include it in their search results. It's not sufficient to assume that everyone will find your website and use it, and that's one of the goals PRIMRE is aiming to solve. You know, if we could corral the diverse community of web portals and either provide a single access point to them or get them all at the very least talking to each other, we can increase the number of people that are finding what they're looking for, and that's what data discovery is all about. There are also organizational challenges to sharing data. You know, sometimes it's difficult to gain support from sponsorship or leadership, and that can, in many ways, have to do with organizational cultures. You know, if you're a private company, a for-profit company, and you're not in the habit of releasing any information at all just because it might be IP, well, that's something we would encourage you to overcome, or we could help you overcome, because that is just simply not true. There are many quantifiable financial benefits to opening up your information and forming partnerships with other people in the field. There are also organizational challenges just in terms of, you know, review and quality control. Many people are worried about reputational risk. You know, what if there's a mistake in my data? What if somebody notices the error? So that's definitely a concern. There are safeguards we can take to circumvent those issues as well. Many of the tools that catalog data do incorporate some sort of curation procedure where people are reviewing the metadata for mistakes. Fewer of them incorporate reviews of the data itself, but there are those that do. And then, of course, there are financial challenges, and, you know, there's obviously a cost to hosting things online. It can be difficult to determine the real worth of your data, especially when you're in that phase of trying to gain support from leadership or push your organization to release certain things. If you haven't done it before, you don't have metrics on, hey, you made this data available and it turned into 5 new projects for us worth X number of dollars or euros or yen, then you don't actually have the data to back up those pushes in the beginning. That can be difficult. But I think the biggest financial challenge that I've experienced in working in this field for a while is that people usually only think of data at the end of the project life cycle. And that's just unfortunate. It's very common, but it really means like they get to the end of the project, hey, we have this amazing data project, look at all this fantastic research we did. We maybe even want to share it with everyone, but we've already spent all our money. So we'll just write a paper, we'll present it at a conference, and that's good enough. And the answer is, you know, the result is simply not good enough to bury the fruits of your labors in a single paper at a conference at the end of a life cycle. We definitely encourage people in the States, in the Department of Energy, to plan for the data release and information dissemination portion of their project so that it's in their budget and so they know to at least save money for that at the end of the project. We also encourage them to release something early. And so when we do that in the MHKDR, we have placeholders and metadata that say, hey, this data doesn't exist yet, but people are working on it and it will exist soon. And that opens, that federates out to that community of data partners that we have developed and we're working on expanding through PRIMRE. And it really lets people know that this is happening, somebody's working on it, and if you're interested in joining the cause, collaborating, or if you're interested in early copies of the data, there you have the contact for that person right there. So that's a big help as well. There are other challenges of sharing data as well. I'd be interested to hear your institution's challenges, your concerns, and your views in our open Q&A session.